Let's take a look at an example on how to subtract vectors geometrically. So I'm going to give you a vector A that has components 3, 4, and a vector B with components 7, 3. And the goal is to find A minus B. Okay, so one possible way to do that, method 1, is to use vector addition. So A minus B can be rewritten as A plus negative B. And recall, to take the opposite of a vector, you're going to just change the components. So change the signs of each of the components. So negative B is going to be negative 7, negative 3. Okay, and so in the first diagram, I have vector A drawn as a position vector, so starting at the origin, over 3 and up 4. And from the head of vector A, I've drawn the opposite of vector B, because it'll be A plus negative B. And here is negative B. And then the resultant vector, the difference, really A minus B, which is what we're looking for, is this vector in orange, which is the vector A minus B. And you can see it has components counting from where you started, which is at the origin, negative 4, 1. Well, a faster option to subtract vectors is to place them tail to tail, like place them together. And then what you'll do is just draw the difference of the vectors, A minus B, from the head of the second to the head of the first. Okay, so let's label these. So here's A, here's B. If you want to find A minus B, the second one is where you're going to start. Okay, because remember, the vectors will be different depending on which direction you point the arrow. So start with vector B and then point toward vector A, have it end there, and look at those two vectors. They are identical to one another. So this is, again, A minus B. Okay, algebraically, on the other hand, it's a lot easier to subtract vectors. You're just going to subtract their like components. So we can double check ourselves. We would take 3 minus 7, and we get negative 4, and 4 minus 3, and we get 1, and there are the components, negative 4, 1.